Welcome back. Welcome back, everybody. We are on the standing wave ratio and antenna measurement section. So, standing wave ratio, SWR, is a term that you will often hear when talking about antennas and feed lines. It is a measurement of how well a load, such as an antenna, is measured to a transmission line. When we say that an antenna is matched to a transmission line, we mean that the impedance of the transmission line is equal to the impedance of the antenna. If you measure the SWR of a perfectly matched antenna system, the SWR meter will read 1 to 1. The higher the SWR reading, the greater the mismatch between the antenna of the transmission line. Now, in order to get a 1-to-1 antenna, everything has to be perfect. You're almost never going to get a perfect 1-to-1 antenna. It's always going to be 1 point something. So as long as your SWR is below 2 to 1, you are doing good. You're going to be okay. You're going to have some loss. Yes, of course you're going to have some loss. But designing and installing a perfect antenna is next to impossible. It's next to impossible. It's not impossible, but it is extremely difficult to achieve a perfect 1-to-1 SWR. So T9B12, what is standing wave ratio, SWR? A measurement of how well a load is matched to a transmission line. T7C04, what reading on an SWR meter indicates a perfect impedance between the antenna and the feed line, and that is 1-to-1. 1-to-1 is in a perfect world with a perfect antenna. All right. Very, very difficult to achieve. Not impossible, but very difficult to achieve. What does an SWR reading of 4-to-1 indicates? That means you got a pretty bad antenna. Okay? And there's something going on either with the antenna or the feed line. Something is not right. You should not be transmitting at that point. All right? I would even stop transmitting at 2-to-1. All right, once you get to 2-to-1, you need to start looking. The antennas that I kind of build and design, I like to keep them below 1.5. Once I hit 1.5 or even 1.75, most of the time 1.5, I start looking at the antenna. What happened? What did I do differently this time to make it go that high? I really like to have my SWR below 1.5, but below 2.1, you can still transmit. But if you hit 2-to-1 impedance, 2-to-1 SWR, you need to do some tuning to the antenna and figure out what's going on. Or maybe there's moisture in your feed line, something like that. An incident that happened with me a few months ago. Didn't seal up the connection point on the antenna very well. I thought I sealed it, but apparently I didn't do a good job, and moisture got in the feed line. And One day I'm transmitting at a beautiful 1.3 SWR, even less than that in some portions of the band. And then the next day I come in, it is almost in the threes, 2.5, 2.75, somewhere around there. So, started going back and looking at all my connections, making sure everything is connected properly. And yeah, it turned out that the moisture, rain got in there and pretty much destroyed my feed line, my coax. So when the feed line impedance matches the antenna input impedance, the SWR will be low. Low SWR on a coaxial feed line, coaxial cable feed line, is a good thing, because when the feed line impedance matches the antenna impedance, signal losses are low, meaning that the antenna will radiate more power. So what happens when you get a high SWR is your radio starts reducing power. If you are around a 2-to-1 SWR, your radio, and you're transmitting at 100 watts. And most of the radios will have a power meter on there. If you turn that power meter on and you're taking a look at the power meter, when you hit the PTT button, but the push to talk button, you will only see the meter go up somewhere around 50 watts, even less than 50 watts. So even though you got the power cranked all the way up to 50 watts, but you got a 2-to-1 SWR, you're only going to put out maybe 50 watts. All right, so the other 50 watts is you're losing it. So what T9B01 is, what is a benefit of low SWR? Reduced signal loss and power loss as well. The bigger the mismatch is between the feed line and load, the higher the SWR will be. The higher the SWR, the more power loss is, and more power is lost in the feed line. Power converted into heat is not radiated by the antenna. So it basically just turns it into heat. All right. So T7C07, what happens to power lost in a feed line? It converts into heat, which is not a good thing. You want to keep everything cool. So most amateur radio transceiver today will reduce power if the antenna system SWR is high. The reason for this is to protect the radio from being damaged by reflected power. So once you hit your PTT button, your signal goes through your transmission line, it goes to the antenna, and whatever power and signal is not transmitted out of the antenna, it comes back on your feed line and goes back into your radio, which is something that you do not want. That is why you should have a very well-tuned antenna system so no power gets reflected back. Now, there is and that is called common mode current, CMC. So there are also chokes that you should have in your feed line to kind of prevent that common mode current from traveling back in through your coax, through your feed line, back into your radio. And those are called common mode current chokes. All right. Excuse me. So most amateur radio receivers will, like we said, with the high, will reduce power with the high SWR, and so it doesn't get any reflected power, or as least amount of power reflected back into the radio. So T7C05, what do most solid state transmitter why do most solid state transmitter reduce power as SWR increases beyond a certain level to protect the output amplifier transistors, to protect the internal guts of your radio. So you got 1,000, 800, 700,000, 1,500, $2,000 radio. It's gonna want to be protected. It doesn't like power coming back into it, so it's gonna automatically start to reduce power. So when choosing an SWR meter, be sure to note the frequency range over which the meter will operate and the maximum power level at which you can use the meter. Using a meter outside of this specified range can result in enormous readings, and using a meter above the maximum power level can damage the meter. So T4A02, which of the following should be considered when selecting an accessory SWR meter? The frequency and the power level at which the measurements will be made. Most of your antenna analyzers nowadays will have a little knob on there, or some kind of way that you can change frequency and tell it to operate on this frequency between here and here, and it will automatically adjust itself. So an SWR meter is not only a way to measure SWR, you can also measure SWR with a directional watt meter, which is not that common in the ham radio world. Okay, it's just easier to get a hold of an SWR meter. All right, but it is, you can measure it with a directional watt meter. So T7C08, which instrument can be used to determine SWR, a directional watt meter. When using a directional watt meter, you first measure the forward power, then the reflected power, and using those two values calculate the SWR. Since the watt meter measures power, you should install it in the feed line between the transmitter and the antenna. So you gotta have, with the directional watt meter, it's gotta be connected to the radio also, where in just an SWR meter can just be connected directly to the antenna. Okay, an antenna analyzer could just be connected directly to the antenna. You don't need to get your radio involved in it. But with the directional watt meter, you have to get the radio involved in it because it's measuring two sets of information. It needs to have two sets of information. All right, so T4805, where should an RF power meter be installed? In the feed line between the transmitter and the antenna. Another test instrument that you can use to measure the SWR of an antenna system is the antenna analyzer. The SWR of an antenna system will be 1-to-1 at a resonant frequency. So SWR meters, antenna analyzers, those two terms kind of go hand in hand. They're pretty much the same thing almost. So T7C02, which of the following is used to determine if an antenna is resonant at a desired frequency? Antenna analyzers. Some antenna analyzers will also measure capacitive reactance and inductive reactance and also be used as an RF signal generator. These capabilities may be useful in applications other than antenna analysis. So if an antenna impedance is not 50 ohms, the impedance at the transmitter end of a feed line will not be 50 ohms. Don't worry though. You can use a device called an antenna tuner or antenna coupler to transform the impedance from whatever it happens to be to 50 ohms. We call this process impedance matching. Impedance matching. So this is what basically an antenna tuner does, is it matches the impedance. So T9B04, what is the major function of an antenna tuner or an antenna coupler? It matches the antenna system's impedance to the transceiver's output impedance. In addition to instruments that make antenna measurements, it's helpful to have an instrument that can stimulate an antenna. That's the purpose of a dummy load. A dummy load. Basically, a dummy load is just a big 50 ohm resistor that provides a known impedance to the transmitter and converts the transmitter output into heat so that it does not get radiated. If a transmitter operates normally when a dummy load is connected to it, you can be reasonably sure that your transmitter is working properly. So first we were talking about how to test your antennas. Okay. Now we are going into testing your transceiver, your radio itself. So T7C01, what is the primary purpose of a dummy load? To prevent transmitted signal over the air when making tests. It's basically an antenna that will not transmit. All right, that's just for testing. So what does a dummy load consist of? A non-inductive resistor mounted on a heatsink. Excuse me. So amateur radio signals. Modulation modes and signal bandwidth. So modulation is a process of adding information to a radio wave. For example, to send a voice signal, you modulate the radio waves with your voice. Modulation is putting your voice into a radio. All right. So there are several different types of modulation, but when you get your technician license, chances are that frequency modulation, which is FM stands for frequency modulation, or phase modulation, PM. Phase modulation is PM. Is a type of modulation that you'll use first. When you frequency modulate or phase modulate a radio signal, the audio actually changes the frequency of the signal a little in proportion to the volume of the audio signal. So the louder that you talk, more it's going to change the frequency. All right. An FM receiver detects this frequency change and reacts and recreates the audio, not reacts the audio, recreates the audio. So T8A04, which type of modulation is commonly used in VHF and UHF, FM or PM? Frequency modulation or phase modulation? All right. Packet radio is a way to send digital information or VHF. This is usually done using FM or PM signals. The digital information is sent by changing the frequency of the audio. For example, a VHF packet transmission with data of 1200 baud normally uses a frequency of 2200 hertz. For the space and 1200 hertz for the mark. This is going to come into play in our next general section as well. A lot of this information that you're learning in the technician is going to carry over into general. All right. So the more time you spend on technician, studying for the technician exam, the easier it's going to be when you get to your general exam. All right. So T8A02, what type of modulation is commonly used for VHF packet radio? Again, frequency modulation or phase modulation, FM or PM? Amplitude modulation. Now we're getting into AM. Amplitude modulation or AM is another type of modulation. To amplitude modulate a signal, you vary the amplitude of a signal in proportion to the audio level. Single sideband or SSB is a form of amplitude modulation. SSB is a better choice than FM for long distance, weak signal contacts on VHF and UHF band because it is more energy efficient than FM. And this is important when trying to send signals long distance. So all of your HF communications, pretty much from 10 meters and up, is done on single sideband. All right, whether it's going to be upper sideband or lower sideband, that's going to depend on the band that you're operating in. But it is always going to be a single side band. All right. So which of the following is a form of amplitude modulation? AM, SSB, single sideband. All right. All this is going to come back to us in the general exam. So again, please pay and spend a lot more time, as much as you can, on the technician exam, because it is setting the base, it is setting the foundation for the next exams that are coming up for you. All right. Very, very important stuff that's going to keep coming back. They're talking about SSB here again. So which type of voice mode is often used for long distance contacts in VHF and UHF bands? SSB. So a single sideband signal may be upper sideband or lower sideband on frequencies above 14 megahertz. Amateurs normally use upper sideband. So above 14 megahertz, which is your 20 meter band, you're going to be using upper sideband. All right. So T8A06, which sideband is normally used for 10 meter HF, VHF, and UHF signals, upper sideband. So the audio of an FM signal sounds better than an AM signal, but it occupies a wider bandwidth than an AM or a single sideband. This means that you can have fewer FM signal in a given frequency range than a single sideband signal. An SSB signal is typically 3 kilohertz wide, while a VHF FM repeater voice signal is 10 to 15 kilohertz wide. So when you are transmitting on your little HTs, your handheld talkies, you're taking up 10 to 15 kilohertz of space. Excuse me. And when you're talking on HF, you're only taking up 3 kilohertz. All right, 3 kilohertz. If I'm not mistaken, the correct is 2.8. 2.8 kilohertz wide is your signal, a single sideband signal in HF. 2.8. So we just rounded up to 3 kilohertz. So T8807, what is a characteristics of a single sideband compared to FM? SSB signals have narrow bandwidth. Approximate bandwidth of a typical SSB voice signal, 3 kilohertz. T8809, what is the impedance bandwidth of a VHF FM voice signal, VHF repeater FM voice signal? 10 to 15 kilohertz. 3 kilohertz compared to 10 to 15 kilohertz. Almost 5 times wider. It takes up 5 times more real estate than the signal on HF. Another disadvantage of FM compared to SSB signal is that you can only receive one signal at a time. When 2 signals are present at the input of an FM receiver, the receiver will suppress the weaker signal and only demodulate the stronger signal. This is known as the capture effect. That is how us POTA people we that's our bread and butter. We most of us, when we are dealing with a pileup, we are going to pick out the weak signal out of a pileup, because we know that people who are running the 1,000-watt stations, the 1,500 stations, they're not going to go anywhere. But the QRP stations, the low power stations, or the mobile stations that some of them have very weak signals. We don't know how long we will be able to hear them. Propagation changes every second, every split second. Propagation changes. So if you don't pick out, when you're doing an activation at a park, if you don't pick out the weak signals right at the beginning, you might lose them on the next go around. All right. So T8812, which of the following is a disadvantage of FM compared to a single sideband? Only one signal can be received at a time. Some modes have very wide bandwidth, such as AM fast scan TV. Yes, you can send pictures over radio waves. All right. Analog fast scan color TV signals are sometimes referred to as NTSC signals because the standard of this type of signal was established by the National Television System Committee, or the NTSC. So T8A10, what is the approximate bandwidth of AM fast-scan TV transmission? About 6 megahertz. 6 megahertz. T8D04, what type of transmission is indicated by the term NTSC? And that is your analog fast scan color TV signal. Morse code, CW, which stands for continuous wave. Signals, Morse code or CW signals have a narrow bandwidth than either the AM or the FM bandwidth of a CW. Sorry, let me read that again. Morse code or CW signals have a narrower bandwidth than either AM or FM. The bandwidth of a CW signal is approximately 150 hertz. 150 hertz. That is the smallest real estate that any signal can take, is your CW, Morse code, continuous wave. Technicians have CW privileges on 80, 40, 15, and 10 meter bands. So believe it or not, as soon as you pass your technician exam, you can actually communicate on HF on just about every single band there is, as long as you know CW. As long as you know CW. So 10 meter bands, as well as all the VHF and UHF and microwave bands. So T8D09, what is CW? Another name for Morse code transmission, which stands for continuous wave. Continuous wave. T8A05, which of the following types of signal have the narrowest bandwidth? Narrowest bandwidth. Continuous wave. What is the approximate bandwidth required to transmit a continuous wave signal? 150 hertz. 150 hertz. To send Morse code, you need a straight key or a paddle. Those are two types of keyers that you transmit CW with. So a straight key has one set of contacts, and you make the dits and the das manually by holding it down for different lengths of time. A paddle, on the other hand, has two sets of contacts which are connected to an electronic keyer. When one set of contacts is closed, the electronic keyer sends dits. When the other set is closed, the electronic keyer sends the das. All right. So T4A12, what is an electronic keyer? A device that assists in manually sending Morse code, in manual sending of Morse code. All right. This looks like a good spot to stop. Thank you very much again for coming back and looking at these videos. Please study. This is not rocket science at all, but it does require just a little bit of studying. All right. And if you spend a little bit of time on the technician license, you will get a nice and firm foundation for what is going to come on the general exam, on the general. So thank you again for joining, and have a great day.